Hello dear students, I am Ikhlaq sir, resonance class Handwara physics faculty. So here we will be starting with the ray optics, and the topic number first of the ray optics is what? That's reflection of light from the plane mirrors, and we will be starting with the basics, and that is the first basic point is what? That's laws of reflection. All right, so let's start with this. So first of all we will be starting with what? With the laws of reflection. So this is the laws of reflection. Okay, so before discussing the laws of reflection, I'll first of all make a diagram here. Let me make a diagram here. So this is the diagram. This, for example, the mirror. Okay, now this is the polished surface of the mirror. All right, the next what I will do is this: I will try normal to this mirror. So this is the normal to the mirror. Normal implies simply a line which is perpendicular to the plane of the mirror. All right, then there is what we call as incident ray, and then there is reflected ray. So here we have this called as the incident ray, and this ray is called as the reflected ray. Okay, so this here incident ray IR, this here normal, and this here reflected ray. All right, okay, then we define what we call the angle of incidence. So how we define angle of incidence? Incidence is defined as that angle which the incident ray makes with the normal. So this angle is called as the angle of incidence, and this angle is called as the angle of reflection. All right, moreover, this angle is defined as the phi, so this is called as the glancing angle, or this angle is also defined as the phi, that's also equal to glancing angle. These two angles are defined as glancing angle, this angle of incidence, this angle of reflection. Okay, so let's discuss one by one what are the laws of reflection. There are two laws of reflection, law number first and law number second. All right, law first and law second. Okay, so what is the law number first? What is the first law of reflection? First law of reflection states that the angle of incidence is equal to the angle of reflection. Okay, so let me write it down here, that the angle of incidence is equal to angle of reflection. All right, so this angle is equal to this angle. If this angle is equal 30 degree, then this angle will be also equal 30 degree. If the angle of incidence is 60 degree, then the angle of reflection will be also equal to 60 degree. Okay, जो बेटा ये law है, we are not going to prove that law here. We'll be proving it later on in the wave optics using what we call as the Huygens wave theory. Okay, so first law is what? Angle of incidence is equal to angle of reflection. Point number first. Moreover, this angle, these two are the glancing angles. Glancing angle implies that angle which the incident ray makes with the mirror. So those two angles are also equal. For example, this angle is equal to 30. तब ये angle कितना होगा? ये होगा 60, and this will be 30, and this will be also equal to 60. Simple, because all these angles they form a linear pair of angles, or these two are complementary. If this angle of reflection is 30 degree, तब phi कितना होगा? That will be obviously equal to 60. If angle of reflection is now 30, then angle of incidence will be 30, and this phi will be again equal to 60. Next point is that this incident ray, this normal, and this reflected ray, they will lie in one plane. That's the law number second. So what's law number second is this, that the incident ray, reflected ray and normal lie in one plane. They lie in the same plane. They will lie in a plane. All right, so they will lie in a plane. When they will lie in a plane, we are going to have a mathematical statement for this, that the incident ray, reflected ray, and the normal, they will lie in a plane. Okay, so what I will do for that, what I will do is I will define the three unit vectors here. One unit vector along the incident ray is like this, and that's here I cap. What is this I cap? It's the unit vector along the incident ray. All right, and here I will define one more unit vector. वो क्या है बेटा? That's r cap. और ये r cap क्या है बेटा? R cap is the unit vector that's along the reflected ray. Great. And then there is this n cap, and what is this n cap? This n cap is the unit vector along the normal. Then you know that from the vectors, from the knowledge of the vectors, you know that if there are three vectors which are coplanar, their scalar triple product will be equal to 0. Now here we have three unit vectors, that's I cap, n cap, and r cap. They lie in a plane. When they will lie in a plane, so their scalar triple product must be equal to 0. Great. So here I will write down I cap dot n cap cross r cap must be equal to what? That's equal to 0. This is the mathematical statement of the second law, that the scalar triple product of the three unit vectors which lie along the three different lines, incident ray, reflected ray, and normal, their scalar triple product must be equal to 0. Okay, so these are the two basic laws of reflection. ये आपने class 10th में already पढ़े होंगे. Okay, so we have revised them here. Okay, next, so what you'll now, what's important from the laws of reflection is simply this, that this is the mirror, and this is the normal to the mirror, this is the incident ray, this is the reflected ray. All right, so this is the incident ray, and what about this is the reflected ray, this is the normal, this is the mirror here. All right, so now what I will write down is this angle of incidence must be equal to angle of reflection. तो इसका मतलब क्या है बेटा? For example, this angle is theta. अगर ये theta होगा तो ये वाला एंगल भी थीटा होगा. If this angle is equal to phi, then this angle is also equal to phi. Where phi, that's called as glancing angle. This angle is defined as glancing angle. It is named as glancing angle. ठीक है बेटा? So those two angles are also same glancing angle. Okay. Next, what I can write down is this important point here is this, that this theta plus phi must be always equal to 90 degree because they are complementary. Okay, because this is the normal to this. All right. Okay. So we are done with this. Next important point here is this. Next important point. So let me write down the important point here. Okay. So there are two technical terms here. One is called as the normal incidence. One is called normal incidence, and second is called as the grazing incidence. Normal incidence and grazing incidence. So let me define them one by one. So first technical term is what? That is normal incidence. That is normal incidence. That is normal incidence. Okay, so what we mean by normal incidence? Simply, normal incidence implies when the ray of light is incident normally on the mirror, and when the ray of light is normally incident on the mirror, so what is the angle of incidence? Obviously 0 degree. When the angle of incidence will be equal to 0, what about the angle of reflection? That has to be 0 degree. That means when the ray of light is normally incident on the mirror, the reflected ray, it will retrace its path. It will move along the same path as that of the incident ray. So it is like this. It is like this. For example, here we have a mirror, and you know that this is the normal to the mirror. All right. Now a ray of light is along the incident ray. So this is the incident ray. And what is the angle of incidence? So in this very case, angle of incidence is simply equal to 0 degree. And what about the angle of reflection? That has to be 0 degree as well, because the angle of incidence must be equal to angle of reflection. So that means the reflected ray will go in the same direction, in the sorry, not in the same direction, but in the opposite direction, but will retrace its path. So in this very case, the ray of light that retraces its path here, let me write it down, that ray of light retraces its path. Ray of light retraces path. Ray of light retraces path. All right. So ray of light in this very case that retraces its path. So this is a technical term which you must know. Next, there's one more term, and that's grazing incidence. So let me write down here is this, that is grazing incidence. ठीक है ना बेटा? You must be well acquainted with the grazing incidence as well. What we call as the grazing incidence. Simply grazing incidence इसका क्या मतलब है बेटा? इसका मतलब ये है simply the angle of incidence is, you know that that's called angle of reflection. If the angle of incidence is tending to 90 degree, for example, it is something like 89.999 degrees. In that very case, तब the angle of reflection कितना होगा? Obviously, it will be tending to 90 degrees. Obviously, it will be equal to 89.999 degree. ठीक है बेटा? So that's what I will write down is this, that the angle of incidence is tending to 90 degree. Then what about the angle of reflection? That will be also tending to 90 degree. Okay? So angle of reflection will be also tending to what? That will be tending to 90 degree. Simply, it's like this. For example, here we have the normal to the mirror, and if the incident ray is something like this, then the reflected ray will be like this. Okay, so this angle is approaching 90, then this angle will be also equal to approaching 90, because angle of incidence must be equal to angle of reflection. All right. Okay, so what's normal incidence? Simply, if angle of incidence is equal to 0 degree, angle of reflection will be equal to 0 degree. That in turn means that if the incident ray is there, which is normal on the mirror, then the reflected ray will be also normal on the mirror, which in turn implies that it will retrace, the ray of light will retrace its path. Then number second is that if the angle of incidence will be tending to 90 degree, then what about the angle of reflection? It will be also tending to 90 degree. Okay, so we are done with the basic technical terms here about this. Okay, next अब यहाँ पे next एक let's do a simplest example here. Let's do a simplest example here. Okay, so what I will do is this, let me show a simplest example for you here. So example is simply like this. यहाँ पर एक example है बेटा, that's like this. For example, it's given to you that this is a mirror. This is a mirror. Now you know that this is the normal to the mirror, and this one is the incident ray. This one is the incident ray, and when this incident ray, so this is the reflected ray. Okay, now this angle is given to you. This angle is, for example, let's suppose it is given to, it's equal to 30 degree, and you will have to calculate the remaining angles. ठीक है ना बेटा? Okay, so easily we can do it. So if this angle is 30 degree, then what about this angle? This has to be 30 degree. Why it has to be 30 degree? Because the angle of incidence will be equal to angle of reflection. Angle of incidence 30, angle of reflection कितना होगा? 30. And moreover, this is perpendicular. So these two are complementary. अगर ये 30 होगा तो ये वाला angle कितना होगा? It will be equal to 60 degree. Then what about this angle? It will be equal to 60 degree as well. All right. because simply 30 plus 60 is equal to 90. Moreover, the summation of all these angles, they lie in a straight line, so that will be equal to 180, like 60 plus 30 is 90, 60 plus 30 is 90, 90 plus 90 is equal to 180 degree. Okay, then there is another concept, a basic concept, and that is how we define angle of deviation. Another important, another conceptual point here is angle of deviation. Angle of deviation, simply angle of deviation, okay, implies that it is that angle through which the incident ray gets deviated from its actual path. Simple. Or the angle through which the incident ray gets rotated from its actual path. Simple. So for example, here we have this is the mirror, this is the mirror. All right, great, perfect. Now this is the normal to the mirror, this is the normal to the mirror, and here we have what we have is this. What we have is this is the incident ray. When this is the incident ray, so obviously this is the reflected ray. Now, for example, this angle of incidence, suppose it is equal to I, then angle of reflection is equal to R, which will be in turn equal to angle of incidence, because angle of incidence must be equal to angle of reflection. Okay, now this is the initial direction of the incident ray, this is the initial direction of the incident ray, and this incident ray, it has got rotated by this angle, it has got rotated by this angle. This is the angle by which it has got rotated, and this angle is called as the angle of deviation. This is called angle of deviation, simply that angle by which the incident ray got rotated, number one, or that angle by which the incident ray got deviated. So that's called the angle of deviation. Now it's obvious that this angle plus this angle plus this angle must be equal to 180 degree, because all these three angles, they do lie on a straight line. So that's what I will write down here. Let me write down here, it is angle of incidence plus angle of reflection plus delta will be equal to 180 degree or pi radians. All right, now you know that angle of reflection is equal to angle of incidence, तो इस r के बदले हम लिख सकते हैं बेटा I, so it will be I plus I, that's equal to twice I plus delta is equal to 180 degree. All right, now we have to calculate delta. So what is the value of delta? Delta is simply equal to 180 degree minus twice angle of incidence. Okay, that's great. So this is the answer, or you can write down like this, you can write it like pi minus twice I, where pi is the pi radian. All right, so we'll use the equation number first or the equation number second. That will depend. If the angle of incidence is given in the degrees, then the equation to calculate the angle of deviation will be delta is equal to 180 degree minus twice I. If the angle of incidence is given in the radians, like pi by 3 radian or pi by 6 radian or pi by 4 radian, whatever, then in that very case you will use this equation to calculate the angle of deviation. All right, okay, so let's do an example on the angle of deviation. Simple question है बेटा ये. Example is simply like this, that this is the mirror that is given to us. Great. This is the mirror given to us, and you know that this is the normal to the mirror. Now this ray of light is the incident ray of light, and this angle is angle of incidence, and angle of incidence is given to you. It's equal to, for example, 30 degree. Angle of incidence is how much? That's equal to angle of, that's equal to 30 degree. And what you have to calculate is this, you will have to calculate the angle of deviation. What you have to calculate is angle of deviation. So let's try to calculate the angle of deviation simply using the formula that angle of deviation is equal to 180 degree minus twice angle of incidence. So it is equal to 180 degree minus twice angle of incidence. यहाँ पर angle of incidence है कितना बेटा? That's equal 30. So here I will write it down 30. Now 2 into 30 is equal to what? That's equal to 60. 180 minus 60 is equal to 120 degree. So the angle of deviation comes out to be 120 degree. Moreover, you must know what is the sense of this deviation. What is the sense of this rotation? Okay, so how you can calculate that? For example, here we have this is the angle of and this is the incident ray, and this is the reflected ray, and this is that angle of deviation delta. Obviously the sense of this rotation of the delta is what? That is anti-clockwise. So let me write down here, that's anti-clockwise, ACW. And what is this ACW? It simply implies anti-clockwise. Okay, so we are done with the basic terms here. Number one, let me revise it quickly. Number one, point number first is this, that the angle of incidence is equal to angle of reflection. The glancing angles are also same. Phi is equal to phi dash. Point number first. Point number second is that incident ray, reflected ray, and normal will lie in one plane. And what we mean by that, that means I cap dot n cap cross r cap will be equal to 0. The scalar triple product of these unit vectors is 0. And then point number third is that, what we mean a normal incidence, we have defined what's called as the normal incidence. We have defined that as well. Simply normal incidence implies that angle of incidence equal to angle of reflection equal to 0 degree, or if the ray of light is normally incident in the mirror, it will retrace its path Then another point is grazing incidence. Another point is grazing incidence. Grazing incidence implies that if the incident ray is nearly parallel to the mirror, then the reflected ray will be also nearly parallel to the mirror. Or that means if the angle of incidence is approaching to 90 degree, then the angle of reflection will be also approaching to 90 degree. The next point is what? Next point is this, that the angle of deviation is simply equal to 180 degree minus twice angle of incidence. Okay, from this very equation you can calculate what is the angle of deviation. Moreover, you can calculate the different angles. If for example just one angle is given to you, if angle of incidence is given to you, you can calculate angle of reflection, you can calculate the glancing angle, and from there you can calculate the angle of deviation as well. All right, okay, so this is the summary of what we have studied as of now. Okay, next there's an important subtopic, and that's like this, on which consistently the questions are asked, and that's like this: the incident ray and the mirror is rotated. If for example the incident ray is rotated, what will happen to the reflected ray? By what angle will it get rotated? Number second is that if the mirror is rotated, then again what about the reflected ray? Okay, and in case in optics, for every problem there is a shortcut technique. First of all, you will have to learn the concept and then follow the shortcut technique if you want to crack the competitive exam questions, the previous year questions. Okay, so let's have a discussion on this. Simply it's like this. First of all, what we have is this is a mirror. This is a mirror. All right, great, perfect. And this is the normal to the mirror. ठीक है ना बेटा? And this is what we have, the angle of this here, the incident ray. This is the incident ray. And this, what about this? This is the reflected ray. This is the reflected ray. Okay. Now obviously you know that the angle of incidence will be equal to angle of reflection. You know that. You know that. Let's suppose that this angle is equal to, suppose it is equal to 60 degree. If this angle is equal to 60 degree, what about this angle? Obviously it has to be 60 degree as well. Obviously it has to be 60 degree as well. Now the question is like this: if the incident ray is rotated, and there are obviously two choices. Incident ray can be rotated clockwise, incident ray can be rotated anti-clockwise. Let's first of all rotate the incident ray clockwise. So incident ray is rotated clockwise from here to here. So this is the new position of the incident ray, and it is rotated, suppose, by an angle of 10 degree. It's rotated by an angle of 10 degree. All right, okay, incident ray rotated by an angle of 10 degree. What will be the new angle of incidence? This is 60, this is 10. Obviously this angle is how much? That's equal to 50 degree. Okay, that's 50 degrees. So what is the new angle of incidence? So here I will let me write down here that the angle of incidence was what? That's equal to angle of reflection, that's equal to 60 degree. And the new angle of incidence is what? That's equal to, now that's equal to 50 degree. And when that's equal to 50 degree, that has to be equal to the angle of reflection as well. तो जो नया angle of reflection होगा, that will be equal to 50 degree. Okay, so when that's equal to 50 degree, so that in turn means that this reflected ray also got rotated by the same amount, such that the new angle of reflection will be equal to 50 degree. If this angle is 50, अब ये angle कितना होगा? This angle will be also equal to 10 degree. So that this 50 degree plus 10 degrees equal to what? That's equal to 60 degree. This equal to 50 degree. 50 degree plus 10 degrees equal to 60 degree. So that means the incident ray is rotated anti-clockwise, clockwise. The reflected ray got rotated clockwise by the same amount. This is rotated by 10 degree. This also rotated by 10 degree. Now let me summarize it here. What I will write down is this, that this is an important point, that the theta r, what is this theta r? Theta r is that angle by which the reflected ray gets rotated, is equal to minus times theta I, is equal to minus times theta I, why negative sign implies the opposite sinus. What does that mean? For example, the incident ray is rotated by an angle of 10 degree clockwise, reflected ray will get rotated by an angle of 10 degree clockwise, anti-clockwise, so that the law of reflection is not violated, that's always obeyed. ठीक है ना बेटा? Number one. Number second is that, for example, the incident ray is rotated by an angle of 15 degree clockwise, reflected ray will get rotated by an angle of 15 degree anti-clockwise. That's what this negative sign implies. Okay, so theta r is simply equal to minus times theta I. Next, what we'll be going to do is that we'll be now rotating the mirror. When we'll rotate the mirror, what we'll see is this. So this is the point number first. This is the point number first. Point number second is this theta r. Again, what is this theta r? Theta r is the angle through which the reflected ray gets rotated. It is equal to plus twice theta m, plus twice theta m. Okay, let me explain this second equation to you. Equation number first, I think that's crystal clear. Let me explain the equation number second to you. Okay, so this is what we'll be doing. So here we have, this is a mirror, this is a mirror. All right, great, perfect. This is a mirror. Okay, now let's draw a normal to the mirror. Let's draw a normal to the mirror. So this is the normal to the mirror. And let's draw the incident ray and the reflected ray. So this is the incident ray and this is the reflected ray. Great, perfect, perfect. Now for example, let's suppose that this angle is equal to 30 degree. So when this is 30 degree, तो ये angle of reflection कितना होगा? It's equal to 30 degree. It's also equal to 30 degree. Now next what we'll be going to do is that we'll be rotating the mirror like this. For example, this is the mirror. We'll be rotating the mirror. Okay. So this mirror is now rotated like this. Suppose that it's rotated clockwise. Let's rotate clockwise. When the mirror is rotated, so the new position of the mirror will be something like this. It is rotated, suppose by an angle of 10 degree, or for example by an angle of 5 degree or 10 degree, whatever. Let's rotate this by an angle of 10 degree. Okay, so it is rotated by an angle of 10 degree. Perfect. It's rotated by an angle of 10 degree. So this will be the new position of the mirror. This will be the new position of the mirror. It is rotated by an angle of 10 degree. When the mirror is rotated by an angle of 10 degree, when the mirror is rotated by an angle of 10 degree, its normal will also get rotated by an angle of 10 degree. So this will be, this is here M, and what about this? This here N dash. It is here what? That's equal to 10 degree. Clear to you? Because normal is normal. If the mirror is rotated, the normal to the mirror will also get rotated by the same amount like this. This is the normal. If the mirror gets rotated, the normal also gets rotated like this by the same amount. Great, perfect. Okay. अब आप बोलो मुझे, so first of all, what is angle of incidence? First of all, that's equal angle of reflection, and that's simply equal 30 degree. Great, perfect. Now what is the new angle of incidence? You check that out. What is the new angle of incidence? Angle of incidence is defined as that angle which the incident ray makes with the normal, and that's this. That is this. This is the new angle of incidence. So that's obviously equal to 30 degree plus this 10 degree. So that's equal to 40 degree. New angle of incidence is equal to 40 degree with respect to new normal. Great, perfect. This here reflected ray. This is the reflected ray. You know that this is the incident ray and this is the reflected ray, isn't it? Okay. Now when the angle of incidence changes from y to y, from 30 degree to 40 degree. So what about the angle of reflection? It will also change from y to y, from 30 degree to 40 degree. So that means the new angle of reflection, the new reflected ray will be like this. This will be the new reflected ray. This will be the new reflected. This here R, this will be the new reflected ray. So this here R dash, this here R dash. All right. And what about the new reflected angle of reflection? वो कितना होगा? वो होगा बेटा 40 degree. What that will be? That will be equal to 40 degree. So with respect to this angle is equal to 40 degree. This angle is 40 degree. And what we are supposed to calculate is this angle. अब अपने ये angle निकालना है, because we have to calculate that angle by which the reflected ray gets rotated. Okay. First of all, there's incident ray. Incident ray makes an angle of 30 degree with the normal. So initial angle of incidence is 30. Angle of reflection must be equal to 30, because angle of incidence will be equal to angle of reflection. Now the mirror is rotated by an angle of 10 degree. When the mirror is rotated, obviously normal is rotated by an angle of 10 degree. The new angle of incidence will be 30 plus 10, that's equal to 40 degree. New angle of reflection has to be 40 degree. We are supposed to calculate this angle. Now how to calculate this angle? You check that out. How to calculate this angle? Okay, so what about this angle? What about this angle? How much is this angle? This equal to 30 degree. What about this angle? This equal to 10 degree. Can we calculate from there what is this angle? Can we calculate from there what is this angle? Obviously this is 30, this is 10, this total angle is 30, so 30 minus 10 is equal to 20. So this angle will be equal to 20 degree, isn't it that? So this angle is 30, this is 10, 30 minus 10 will be equal to 20. Great, perfect. अब ये पूरा angle कितना है? 40 degree. This is 40, this is 20, obviously this has to be 20 as well. So that 20 plus 20 is equal to 40. Again, let me revise it. This is 30, this is 10, this angle will be equal to 20 degree, because 20 plus 10 is 30. Perfect. If this angle is 20 और ये पूरा angle 40 degree है, so this has to be 40 degree, so 20 degree, sorry. So that means the reflected ray gets rotated by an angle of 20 degree. Here I will write down that the reflected ray gets rotated by an angle of 20 degree. When the angle of incidence, when the mirror gets rotated by an angle of 10 degree, the reflected ray gets rotated by an angle of 20 degree in the same sense. Okay. Now here I will summarize all this. Point number first, the reflected ray gets rotated by an angle of minus theta I. Point number first, when the incident ray rotated by an angle of 10 degree, reflected ray also rotated by an angle of 10 degree in the opposite sense. That's what negative sign implies. Point number second, when the mirror gets rotated, in that very case theta R is equal to plus twice theta M. Because you see that the theta m is equal to 10 degree, the mirror is rotated by an angle of 10 degree, reflected ray gets rotated by an angle of 20 degree. So it is plus twice theta m, and that too in the same sense. Mirror rotated by an angle of 10 degree clockwise, reflected ray rotated by an angle of 20 degree clockwise. Okay, now combining the effect of both these, if for example the question is like this, that the incident ray is rotated by an angle of 5 degree. ठीक है ना बेटा, concentrate on this. If the incident ray is rotated by an angle of 10 degrees, suppose clockwise, and the mirror is also rotated by an angle of suppose 20 degree clockwise, what about the reflected ray? What about the reflected? This equation will give you that. So the combined effect of the two will be what? This will be a theta. I am not adding these two equations. Keep in mind, I am not adding these two equations. What I am trying to say is that if for example both the incident ray and the mirror both are rotated, then the question becomes even more complicated. But with the help of this problem, you can solve any damn question, any difficult question you can solve. Okay, so theta r किसके बराबर है बेटा? That will be equal to minus theta I plus twice theta m plus twice theta. This is the most important equation. As of now, this is the most important equation. ठीक है ना बेटा? From this equation, what you can do is that you can calculate by what angle the reflected ray gets rotated. If, for example, it is given to you that the incident ray gets rotated by this angle and the mirror is rotated by that angle, what to calculate, how to calculate by what angle the reflected ray gets rotated. This is the equation with you. All right, okay. So you focus on this equation. ठीक है ना बेटा? It is highly important. Let's check it out. तो यहाँ ध्यान दीजिए बेटा. So let's do an example like this. So example is like this simply. Example is like this. For example, here we have a mirror and this is the normal to the mirror and this is the incident ray. Suppose this angle is given, this equal 30 degree. Okay, now this is the normal, this is the mirror and this normal the mirror. Great, perfect. Now it's given to you that theta I, that the incident ray is rotated by an angle of suppose 10 degree clockwise, by an angle of 10 degree clockwise, given to you. Incident ray rotated by an angle of 10 degree clockwise. Then mirror is rotated by an angle of suppose it is given to you 12 degree clockwise. 12 degree clockwise. Calculate theta r. What you have to calculate is this. You have to calculate by what angle is the reflected ray rotated. Okay. Simply what you will do is this. You will simply use the equation that this theta r is equal to minus times theta I plus 2 times theta m. But do take care of the directions. Do take care of the directions. So here I will write down theta r will be equal to minus, what about the theta I? That's here 10 degree clockwise. So let me write down 10 degree clockwise. Great, perfect. Plus 2 multiplied with theta m. What is theta m? That's 2 into 12 degree. And what about the sense? That sense is clockwise. Great, perfect. That's 2 into 12 degree clockwise. ठीक है ना बेटा? Now have a look on this. This here minus 10 degree clockwise. What's it? Minus 10 degree clockwise. Negative clockwise implies anti-clockwise. So this is obviously equal to what? It is 10 degree anti-clockwise. ACW plus this here 24 degree clockwise. What is it? 24 degree clockwise. Now there are two angles. One is 10 degree anti-clockwise, 24 degree clockwise. Obviously the two will be subtracted because they are in the opposite direction. So 24 degree minus 10 degree, what is that equal to? 14 degree, and that to clockwise, because जो बड़ा वाला angle है, it senses what? That's clockwise. So finally we are here with the answer, that's theta r is equal to 14 degree clockwise. Okay, you do not construct any ray diagram. आपको ray diagram बनाने की कोई ज़रूरत है ही नहीं. Simply what you can do is this, you can use this formula and to calculate and to solve any difficult question. Okay, so this was an example for you, and you can do the example, number of examples yourself. Take a beta. Okay, so let me summarize it again. So here we have the equation number first we have is this, that this theta r is equal to what? That's equal to minus theta I plus 2 times theta m. Okay, great, perfect. We had an example on this. You can do yourself a number of questions on this. Okay, but take proper care of the directions. Simply आपको याद क्या रखना बेटा? Minus clockwise is anti-clockwise, minus anti-clockwise is clockwise. And if for example there are two angles, clockwise plus clockwise, they will be added and the direction will be clockwise. Anti-clockwise plus anti-clockwise, they will be added and direction will be anti-clockwise. If for example one angle is clockwise, another angle is anti-clockwise, then obviously they will be subtracted, और जो sense of rotation होगा बेटा, that will be same as that of the bigger angle. Okay, that's obvious, that's common sense. Now अब यहाँ पे ध्यान दीजिए बेटा. So the question can be like this as well. That if for example the incident ray, it is rotated by, it has an angular velocity of 2 radian per second. Mirror has an angular velocity of 4 radian per second, clockwise, anti-clockwise, different permutations and combinations. Then you have to calculate what about the angular velocity of the reflected ray, what about the angular acceleration of the reflected ray. You can do that with ease. What you have to do is this your equation number first, memorize this master equation. memorize this master equation. Next, what you want to do is that you want to calculate angular velocity, you want to calculate angular acceleration. Great, perfect. Differentiate it with respect to the time. The problem is done for us. So next, what you'll be going to do is this: differentiate both sides with respect to time. Differentiate both sides with respect to time. Differentiate both sides with respect to time. All right, so let me differentiate both sides with respect to time. Okay, I'll differentiate this. Obviously I'll get angular velocity, because simply we have this, that is angular velocity omega is equal to d theta by dt. Okay, these are the basic fundamental equations, the circular motion. And then there's alpha, which is the angular acceleration. It is equal to d omega by dt. So twice I will be going to what I'll be differentiating it twice. Okay, so the next equation we'll be getting is this. Next equation we'll be getting is this here: omega r is equal to minus omega I plus 2 times omega m. Again differentiate alpha r equal to minus alpha I plus 2 times alpha m. ठीक है बेटा? And there's a golden thing with these equations, that is, don't memorize these equations, just memorize a single equation. That's equation number first. Once you're done with the equation number first, differentiate once, you will get omega. Differentiate twice, you will get alpha. Okay, so as per a question I have done, that's asked in the NEET 2016. NEET 2016, a question is asked on this, the NEET 2016. Okay, that is the angular velocity of this of this mirror is given to you, and you are supposed to calculate the angular velocity of the reflector ray. Easily you can do it. Simply what you have to do is that you will have to substitute the values. So let me label this as the equation number second. Okay.